Okay, first of all, I would like to take the opportunity to thank Dr. Mancini, Dr. Durande, and Professor Weitz for giving me this opportunity to present my research today. I chose my topic. Dr. Massey actually stole my thunder a little bit. I was going to talk about the fact that I did participate in the co-op program that is with Henkel. Henkel is a worldwide company, and they do have products such as Dial soaps, Purex laundry detergents, Right Guard antiperspirants and deodorants, Schwarzkopf hair care products, and Loctite adhesives. And I worked with them as a co-op student in the fall, and then they did hire me on as a temp in December. And so I've been able to stay there and continue to work with them. I work directly with 3 of the different scientists there. Jesus is one of the scientists who is over bar soaps. I work with him 1 day a week, and then Chris and Ishio are the other 2 scientists that I work with, and they are over body washes, body scrubs, lotions, and products for children. So to start, I'm going to talk a little bit about colloids, and then go into a little more depth about emulsions, and then the micelles that are involved in the emulsions, the interaction energies between the droplets, the breakdown that can happen with emulsions, and then how they apply in personal care industry. So a colloid is actually made up of 2 different phases. There is first the suspended phase, or the dispersed particles, and then there is the solvent phase, or the dispersing medium. And the particles are so small that settling is negligible. However, they will still reflect the light, as you can see. This is called the Tyndall effect, and you can see the laser actually in the solution there. There are different kinds of colloids. We have emulsions. An emulsion is a liquid that is suspended in another liquid, and an example of this would be like salad dressing, oil and vinegar, and you can see the 2 different phases. Then there's foams, and that is a gas that is suspended in a liquid. An example of this would be shaving cream or whipping cream. And then there are aerosols, and these are liquids or solids that are suspended in gases. An example of, or a few examples of those would be hairspray, air pollution, and smoke. And those are just some of them. There are several others, but just named a few. Okay, so now we can see a lot of different colloids in nature. Clouds and fog are both considered a liquid droplets that are suspended in gases. And then in blood, we have the solid cells that are suspended in the plasma. And we've been making colloids for a very long time. Here we have beer, which is actually considered a foam. It's a gas that's suspended in the liquid. A lot of dairy products are considered emulsions. They're liquids that are suspended in other liquids. And then, like I pointed out earlier, we have shaving cream and whipping cream, which are also considered foams. Okay, so now I'm going to go into a little more depth. We have one type of a colloid, which is an emulsion, and like I said before, this is a liquid that is suspended in another liquid. And there are the 2 different phases. There's going to be the hydrophilic, or the water-loving phase, and then the hydrophobic, which is the water-hating phase. And so they have to be bonded with an aid, and that aid is a surfactant. And then in the surfactants, there are micelles. And they, as you can see, have the hydrophilic head and then the hydrophobic tail. And depending on the solution that they are in, they will orient themselves to help bond the 2 phases. Okay, so we have 3 interaction energies that are in emulsions. First of all, we have van der Waals attractions, and there are 3 different types of van der Waals attractions. 2 of them don't really apply, but the third one that's the most important in emulsions is the London dispersion forces. Then we also have the repulsive forces, and the repulsive forces actually counteract the London dispersion forces. And these repulsive forces are created actually with those micelles. The third interaction energy is the viscosity modification, And this is, viscosity is the measure of the flow of the fluid. And this can be increased by adding different things, such as a polymer or salt. Salt is actually a really good thing that you can add to body wash bases. I do it all of the time. In fact, this morning I was working with a salt versus a viscosity curve. Chris wanted me to figure out the different levels of salt that we could add to the body wash base to see how viscous we could make it before it crashes. You can only add a certain amount and then it will crash and then lose its viscosity. So those are the three different interaction energies. Okay, so we talked about how you have to have the surfactant. You also have to have the energy that's added. Because this is a non-spontaneous process, you have to add a lot of energy. For some emulsions, a mixer, a regular mixer, is sufficient. However, other emulsions do require a homogenizer. And a homogenizer is a high shearing mixer that will pull apart and actually, destroy the different droplets so that they can then be formed and bonded. And with the homogenizer, I actually have used it to make lotion and also the body scrub. Okay, so because it is a non-spontaneous process, it is thermodynamically unstable, and so it can break down over time. And there are different ways that it can break down. And the breakdown would be due to the particle size of the suspended phase, the density difference of the droplets and the medium, and the magnitude of attractive versus the repulsive forces between the different droplets. So the first type of breakdown is called creaming or sedimentation, and this is where the external forces are going to exceed the thermal motion of the droplets. And so then they will either settle at the bottom or they will rise to the top. The second type is called flocculation, and this is where the droplets are going to flock or clump together. The one thing to point out about this is that the droplet size actually stays the same size. It doesn't, they don't form together. That is actually what happens in the Ostwald ripening breakdown. The droplets will actually combine. Had ordered what's called an extra cone or a flower cone, which are botanical extracts, which would not be considered a fragrance, but it didn't cover the base at all, and that's actually the extra cone that is sinking to the bottom, and it created a really ugly brown color. So, and it had a really awful smell. So they are not adding any color or fragrance to that one right now. So, okay, I wanted to show you, this is a addition. I actually took this video. I'm going, how do I mute it?
That's fine.
Go ahead and leave it?
Yeah, don't worry about it. I'll do it.
Okay, it's really loud. There's nothing.
Go ahead.
Okay.
Play it.
So, I am adding the fragrance to the body wash base here, and as you can see, it gets really cloudy, and it's kind of a cool effect with the blade, the mixing blade. But the fragrances are really unique because they can actually bond with either the water-based products or the oil-based products. And so after it spins for a while, it will actually orient itself and then it will become clear again. And for some reason, they love clear body wash bases. Like I said, I've made body washes. I've also made lotion. Lotion is really fun to make because you have your oil-based products and your water-based products that you mix in separate beakers, and you have to heat them to pretty high temperatures, mix them slowly, and then they actually go through the homogenizer, but it only takes 30 seconds because the process is so quick. It happens in microseconds. And then the last step is to add sodium hydroxide, and this actually reduces the pH level, and that allows for the polymer to be hydrated, and it's an instantaneous process. It's a really viscous material, and then once you add that, within seconds, it looks like this fluffy lotion, and it's really fun to watch. So then the last one I have is the body scrub, and it's actually my personal favorite because Dial has not done a body scrub in the past. This is their first, and they're developing it right now. Ishil is the scientist that is in charge of it, and she has, I actually made all of these different body scrubs. And as you can see on the top left there, those are the earliest samples that we were making. And you can see that the oil is separated out from the salt. Then they changed the dye color, which I think marketing was the one who decided they wanted to change the dye color. And I don't know if you can see on the right there, we were still having the dye separate out a little bit. But the cool thing is that she's been experimenting with not only the ingredients that are being added, but also the order that they're added. When we first were making it, we were adding the silica, or silicon dioxide, which is actually the support structure in the body scrub, and it actually makes this physical matrix, and so it supports it that way. So we were adding that first, and then we were adding the polysorbate, which helps the dyes go into the body scrub. But she realized, I don't know how she decided this, but since I only work with her one day a week, she decided to add the polysorbate in first and then add the silicon dioxide in after, and it actually helped increase that matrix, and so it's helping suspend the body scrub, or the salt in the body scrub more. And so, like I said, it's my favorite because it's actually being developed right now, and it should be launching next year in 2015. So to conclude, I talked about the different types of colloids. These are the two two phases. We have the suspended and then the suspending phases. We talked a little bit about emulsions and the micelles that are involved with the emulsions, the three different interaction energies, and then the breakdown of emulsions, and then how these apply to the personal care industry. And I'm super excited because I do get to continue on there. I just found out yesterday they are extending my contract for another 6 months. And so I will continue this, and hopefully I'll be there when they launch that in 2015. So, any questions? Yes?
Have you worked on any other products other than soaps and lotions?
No, I pretty much do soaps and lotions. They do have the antiperspirant deodorant just a couple benches over from me, but I haven't ever had to work with that. And then just a couple benches the other direction is the hair care products, which I think would actually be a lot of fun because I did cosmetology years ago, so I eventually think it would be fun to work in that department. But no, I've done bar soaps, I've done body washes, lotions, and that's pretty much it. So.
And you work at the Henkel over there?
Yeah, Henkel right there. It's at 101 Scottsdale. Yes.
Are they doing anything with nanotechnology in relation to this?
Nanotechnology? Not that I know of. Yes, Dr. Matt.
A quick question. With so many different ways that emulsions can break down, it seems like these products would have a short shelf life. Is there anything they add to keep it emulsified?
Well, like I said, they do add the surfactant, which helps bond the two different phases. What else do they add? The polymers, like I said, that will help thicken the body wash bases. And polymers are those long chains of, I think they're fatty acids. And so that will help keep things suspended longer. It's interesting though, because just last week we got in a bunch of body wash and you could see the droplets were actually rising to the surface, and so Chris had to call the production plant and find out what was going wrong with it. And they're actually supposed to shake the polymer before they add it, but because they're in such huge quantities, they weren't shaking it well enough, and so then the two phases were separating. But I think those are pretty much all that they add. So, oh my gosh, I forgot to tell you about one other, hold on one second. There's one other body wash base that's a lot of fun because they add mica to it, which adds that sheen like I was talking about. But a marketing tool that they're using is that they're actually putting in diamond dust, which does nothing for the visual effect, and it actually washes away. But because they can put that on the label, people love it more. So, what do you want to ask?
I would ask if you've done any work around about like natural products.
I know that really the only thing that they've been working on is that fragrance-free body wash that they've been working on with kids. They are also working on creating some, there's a new SLES that they've been using that is formaldehyde-free. So not necessarily natural products, but more eco-friendly products. So, anything else? All right. Thank you so much.